Welcome back. In the previous lecture, we discussed diffusion, its definition, the factor that affect it, its importance and difference between that type of diffusion that we have. In this class, we begin discussion of osmosis. The word osmo means water and sis means process. So combining the two together, osmosis means water process. Now, in this scenario, this is water, this is process. So what is osmosis? It is the net movement of water. That is one, across a semi-permeable membrane. That is two, from a region of higher concentration of water. You see, from a region of higher concentration of water. But look at it. Lower solute concentration. Please do not do mistake. Follow this and try to understand this. I will let you know the differences. Higher concentration of water. If there is higher concentration of water, that means to say there must be what? Lower solute concentration. Water and solute are not the same. Let me illustrate this. Look at the container that contains some water. Look at the container that contains some water. And look at the same container that contains water, but now, if you add salt to this, that salt is the solute. If you add salt to it, what happens? The water level will increase because of the fact that the whole volume of the solution has increased. If you now want them to be at the same volume, you have to reduce the amount of water of this in such a way that the amount of solute will account for the equal amount of water that you remove. So in this case, what happened? The salt that you have added has lowered the water concentration. What happened? And the solute concentration have increased. But in this case, there is no solute. So the solute is low. Why what? Water is high. That's the reason why you need to understand the definition very well. If there is higher concentration of water, automatically there is what? Lower concentration of what? Solute. Are you getting me right? Because these things are the very important keys that many JAMB students don't look at before they choose definition of osmosis, and you believe that I have done it. If you don't careful, I'm so sorry. You must be careful about definition of everything. Now, from the region of what? Higher concentration of water. This also implies that what? Lower solute concentration. Yeah, next what? To the region of lower concentration of water, then solute concentration will high. And this process occurs through where? Semi-permeable membrane. Now, a partially permeable membrane has hole in it. But that hole, you cannot see it. Even Ogbanje cannot see it. Not even Babalawo can see it. But you scientists can see it with something. Use microscope, you will see those holes. Okay? Now, that permits water molecule through, but are small to allow larger molecule to pass through. Are you getting me now? But you can try this. I know that you enter into your room through a particular door passage. Is that not it? I want you to take your car through that passage. Drive your mommy car through. Don't tell your mommy that I'm the one that I tell you that you should drive car through that passage. You just want to perform an experiment. But by miracle, nothing can occur. Your car cannot pass through that passage. Because that car is so big, but you can pass through. So that passage is selective. It allows you to pass through while your car cannot pass through. So that hole also performs the same function. It allows small molecule to pass through while larger molecule will not pass. Now, osmosis can be demonstrated using what? Weiskin tube, filling with what? A solution, and placed in a beaker of pure water. This is it. This thing is used majorly by biochemists, people that purify proteins. We call it dialysis. Dialysis. Let me write it out for you. D-I-A. If you look at the word dia means across. A-C-R-O-O-R-O-S-S. Lysis. This is a process, but the word lyse means break. So dialysis, it is what? It is a process of breaking across. That is something we have to move across. The process that you see here in this diagram, let me clear the board so that you know what I'm talking about. The process that you are seeing in this diagram is what we call dialysis, and I will tell you how it is done. When you get to your final year project at your university, if you are a biochemist, your project may involve dialysis. I'm so sorry that dialytic bag, you have to buy it by yourself. The dialytic bag, they call it Visking bag. You will buy it by yourself. So prepare. There are many ingredients in your final year that you buy by yourself. Federal government of Nigeria, they do not sponsor final year project experiment. You are the one that will pay by yourself. I don't know, maybe you will be lucky by your own during your own generation, when federal government will fully support graduate project, because some graduate projects are actually important in developing a nation. But nobody is seeing into that, but your politician is seeing into using your money to buy cars, to build unnecessary building, to carry women and to drink. Nothing much more. No research support to look into what will develop our environment, Nigeria as a whole. I'm so sorry, that is where you find yourself. If you're likely to be in that post, and if I'm lucky to be there, I will do something that makes sense. And you should be able to do something that makes sense as well. Now, this is what we call dialytic process. This is what we call dialytic bag. What you want to dialyze is a solution that contains protein with many other solutes. Are you getting me now? What you want to do is that you want to remove unnecessary amount of water from the solution. Are you getting me? In order to do that, there is something that we use. We use ammonium sulfate. It is a very good reagent for that process. And for now, you may not know the reason. So ammonium sulfate will be added into the solution and put into the dialytic bag. The reason why we add ammonium sulfate into the solution is to make this place to be a region of what? Higher solute concentration and lower water concentration compared to this outer environment. You can see that the outer environment contains water. What will now happen is that by the time you place this solution into water, this is a solution of higher water. This is a solution of higher solute concentration, but lower concentration of water. So the water will move from the region of lower concentration into what? Into a region of higher concentration. So, the water will move into here, into this place. But listen, in real world dialytic, I'm so sorry that there is some little error in what I said previously. And the reason is that this experiment just tells me that there is some error. It is this experiment. This is a solution that you want to dialyze. It contains unwanted molecule with the protein that you want, or all those things that you really don't want. All those things that you don't want, they are the small ionic molecule like potassium, sodium, water molecule, as well as all those things. But the protein that you want is very large. So the protein cannot pass through the bag. But those small ions can pass through as well as water. In order to make this environment is an environment with lower water concentration. Because what happened? Osmosis occur against the concentration gradient of what? Of water Osmosis will occur from the region of higher concentration of water to the region of lower concentration of water. This is the region of higher concentration of what? Water. There is much more water molecule. Why? This is the region of what? Lower concentration of water. So the water and small ions will pass through this particular thing into this environment. Are you getting me? So once those things pass, your protein will be in this bag, and it will not be pure, but it will be concentrated. That is, the meaning of concentrated is that you will have a large amount of that protein in this dialytic bag. So you can now proceed with whatever you want to do with it. So dialysis, so osmosis is one of the processes that is very important in dialysis, and it's one of the processes that they use to extract urine from somebody that cannot urinate. They use a dialytic bag or something like that. Are you getting me? But we are going to see into that in advanced lecture. Now, this bag here, we magnify it. You can see all the space. You can see all those space. So this is the large molecule. In this case, they want to use it to separate glucose solution. So what happened? These are the small molecule. You see, the concentration of water molecule is very low. So what happened? The water will move from the region of what? Lower concentration to the region of what? Higher concentration. We look at the water molecule here. They are very large. Their number is higher. Are you getting me? When you are talking about concentration, we are talking about number of particles. But there is something that I want you to know in this lecture. Because we are talking about concentration, it's very, very important to you to know how to calculate the concentration. And one of the formula that we are using is based on mole concept, which is equal to what? Number of mole is equal to what? Concentration all over what? All over volume. So in order to calculate the concentration, we use the concentration equal to what? Number of mole multiplied by volume. And how do you calculate number of mole? You know how to do that. But for example, if I want to prepare 0.5 molar of any particular solution, are you getting me? 0.5 molar. I know you really know the meaning of capital letter M. Capital letter M is 0.5 molar. That is, I have 0.5 mole of solute inside 1 liter of solvent, which is water. 1 liter of solvent is 1 dm cube. 1 dm cube is equal to 1,000 centimeter cube. Please get those units right. That is to say, let's take for example the one that is very clear to us. Let us say that you want to prepare a salt solution. Your salt that you are using in your home is what? Sodium chloride. Are you getting me? This is capital letter C. This is small letter L, because 2-letter element representation. So you have sodium chloride. You want to prepare what we call 0.5 molar of that sodium chloride. The meaning is that I want 0.5 mole of the salt inside 1 liter of water. How can you get 0.5 mole of salt? How can you get 0.5 mole of salt? You can get 0.5 mole of what? Salt with this formula. Use this formula. Number of mole is equal to what? Mass all over molar mass. How can I get mass? How can I get molar mass? Let us discuss how you can get molar mass first. This is a sodium. What is the mass number of sodium? The mass number of sodium is known as the molar mass of sodium, which is about 23. What is the mass number of chlorine? The mass number of chlorine is the molar mass of that particular chlorine, which is what? 35.5. Look into your periodic table, you will see what I'm talking about. Sodium, chlorine, and they are 1, 1. If this one is 2, you multiply this one by 2. Are you getting me now? If this one is 3, you multiply this one by 3. You will multiply the value, but it is only 1. So 23 plus 35.5. What is answer? Answer is equal to what? 58.5. 58.5. 58.5. Now, in this scenario, and the unit is just what? Gram. Because we are talking about molar mass. Molar mass is what? Mass inside just 1 mole. So we have 58.8 gram, which is the molar mass of what? Sodium chloride. You want to, what is the mass? Mass, it is something that you will determine using your chemical balance in the lab. That chemical balance is just a small weight that you will be putting salt onto it until you get to particular mass amount. In order to prepare 0.5 molar, the meaning is that you have to put 0.5 mole inside 1 liter. So this is the number of mole, this is molar mass. You are not going to use this formula to calculate the mass of what you want. In order to do that, I will say mass is equal to what? Number of mole multiplied by what? Multiplied by molar mass. So what's the number of mole? 0.5. What is molar mass? Molar mass is equal to what? 58.5. So just look at the mass of individual elements in the compound. It is on your periodic table. So by the time you calculate this particular value, what is this? You are looking at half of 58.5. The half of 50, it is 25. The half of 8 is 4. So 25 plus 1, that is about 29. So if you look at that, you'll be having something like 58.5 divided by 2, which is equal to what? 29.25. So that is to say you need about 29.3 grams. You need about 29.3 grams of salt. You will now take that chemical balance and weigh out 29.3 grams of salt. Are you getting me now? You will put it into a very large conical flask or a round bottom flask that is more than 1 liter. You will put it into it completely. And if there is a way that you can wash that thing so that all the salt can be washed into the thing here, you wash it with only small amount of water. You will add little water and dissolve the whole salt and add water to it until the thing is completed to what? 1 liter. So in that case, you have prepared 0.5 molar sodium chloride. This is how to determine the concentration. I teach you how to do this because it's very, very important to this course. So what are the factors that affect osmosis? Number 1, temperature. Because of the molecular movement. Are you getting me now? It involves movement of water, and the higher the molecule, the higher the kinetic energy. Concentration gradient. So across the semi-permeable membrane. So the higher the concentration of water from one medium compared to the other, the higher the rate of osmosis. Surface area of osmosis is also surface area for osmosis. It has to do with the nature of the surface at which the particular water molecule is moving through. If the surface is so large, water will move much more compared to narrow surface. We also have pressure difference across the membrane, semi-permeable membrane. This is where we discuss the concept of osmotic pressure. And if you have offered pressure in your chemistry, pressure is equal to what? This is what we will call nRT over what? Over V. PV is equal to nRT, so that we have this. So this particular thing here is what will transform to what we call osmotic pressure. So that osmotic pressure is represented with this particular letter. So, and it's equal to what? It's equal to concentration, because number of mole over volume is equal to what? Concentration. So that is concentration multiplied by what? Gas constant multiplied by temperature. So because of the fact that osmotic pressure depends on temperature, temperature will also affect what we call osmosis. And what we call osmotic pressure? Osmotic pressure is the pressure that must be applied in order to prevent osmosis. You cannot understand this on the thing. We'll show you some experiments on how to determine pressure. Now, we have experiment to demonstrate osmosis. And in this experiment, you will see experiment method. There is something missing here, which is apparatus. But for you, please write those apparatus out. You have method, you have observation, as well as your conclusion. So you can also do a co-explanation. So now, what are we talking about in this experiment? They have potatoes, they have beakers, they have sugar solution, they have water solution. What they are doing is that here, you know that potato. If you don't know potato, go to market. Those people that are selling potato. So it is look like a yam, but if you cannot use potato, you can use a yam. Just cut a very high level of yam. Are you getting me? Carve hole into it. Carve hole into it. Are you getting me now? So in that hole, so carve hole into it, and in that hole, add another solution, maybe a salt solution or sugar solution. Are you getting me? Maybe a salt solution or sugar solution, and place it inside a beaker of water. Place it inside a beaker of water. Please note, if you place this inside a beaker of water, let me draw it very well so that you can know what I'm talking about. Some of you don't know how to perform experiments to obtain accurate results. So here, this bottom of the yam will sit inside the beaker, and the beaker will be like that. The beaker may be taller than the yam, but when you want to add your water, add it in such a way that it doesn't cover the yam. Are you getting me now? So determine the level of this water. This is pure water. Do not add anything to the water outside here. Are you getting me? Perform it in the night. Go and sleep and observe it the next morning. By the time you wake up next morning, what will happen is that some water will have moved from this place to this place. From the region of what? Higher water concentration to the region of what? Lower water concentration. Are you getting me? So the water here will have been mushed, while the water here will have go down through the semi-permeable membrane. The membrane is the body of the yam in this experiment. So just read this through experiment and see what you can take from it. I must let you know that osmosis imparts some effect. Osmosis has effect. It has negative effect. It has positive effect. But the effects of osmosis will impart depend on the nature of solution. Now, let us look at the type of solution that we have. We have hypertonic, which is high. We have isotonic, which is equal. We have hypotonic, which is lower. Now, what do we mean by this? You remember that in your experiment, you have something here. We have water here. We have water here. Are you getting me? We are trying to compare the water concentration outside to the water concentration inside. Are you getting me now? So, when we are considering this concentration, we want to see which one is hyper, we want to see which one is hypo, we want to see which one is iso. Iso means equal. Hyper means higher. That is to say, it's a situation where there is higher concentration of water outside compared to inside. Hypo, lower concentration of water outside compared to inside. Equal, that is to say, there is equal concentration of water outside and inside. Now, hypertonic solution, higher solute outside. Can you see? That's case number 1. Higher water inside, case number 2. You don't understand the meaning of this. Please try to remember. It's not difficult. It's just word. Higher solute outside. The meaning of that is lower water outside. Higher solute outside means lower water outside. Higher water inside means lower solute inside. Solute and water is not the same. Solute is something that you added into the water, and I have experimented to you. Okay? Iso means equal, tonic concentration. Equal solute water, equal water. Equal solute, equal water. The reason why this thing is used like this is because inside one molecule there must be solute. Why the one that's outside there must be pure, or there must be water? That's the reason why we are using the one that has solute, we say it with respect to solute. The one that has water, we say it with respect to what? Water. So that's the reason for that. I get me. Why hypotonic solution? In hypotonic solution, there is higher solute inside, higher water outside. In fact, if they give you a question, they may use this statement to confuse you. If you don't know what you are doing, you will get it wrong. So that's the reason why in every process, you must know what is happening. You must know what is moving. You must know what is moving through what, but you must know what is involved in that process? Water moves out, cell shrink. No net movement, cell remain the same. Water moving, cells swell up. Look at this. Let's say this is a cell inside hypertonic solution. Inside hypertonic solution, a solution that contains lower amount of water, hypertonic solution, a solution that contains higher amount of water inside of this particular cell. But outside here, there is lower amount of water. Because you know that water will move from the where that is much more to where there is no water at all. In a hypertonic solution, this is a solution. Are you getting me? This, what is outside is called solution. Are you getting me? If you want to prepare an hypertonic solution, if you want to prepare hypotonic solution, you prepare a solution with pure water. A water that does not even have anything in it at all. And a cell that is coming contain water and some other solute. But in that scenario, water will be very much more inside the cell. In fact, one way you can make sure that you have hypotonic solution so that the water in this place is in lower concentration compared to water in the cell is that you put a very small amount of water into this place. By putting small amount of water, you have lower water concentration. So what happens? Water will move from the region of higher concentration to the region of lower concentration. Please, do you know what will happen to you if you continue to sweat profusely? Before you know it, all water inside you will drain off and you will skin down. You will become narrow. That is to say, all the water inside this thing will be what? Will be pushed out into the environment. So the cell will shrink. The cell what? Will shrink. This process, we call it as what? Plasmolysis. Plasmolysis. Plasma means fluid. Lysis means break. Plasmolysis. What? Fluid breaking out. So it is something that you can remember if you remember lysis and plasma. So plasmolysis, this is plasmolysis. That is to say, if a cell is placed into an hypertonic solution, what effect can osmosis have on it? The osmosis will cause it to plasmolyze. That's what we call the process of what? Plasmolysis. But in isotonic solution, as water moving, water move out, equal amount. So the cell will remain the same. But in hypertonic solution, what happens? Much water will move into the cell and the cell will swell up. That's what we call turgidity, to turgid. So turgidity is one of the processes that plants use to erect their stem up the surface of the atmosphere. So this is one of the demonstration of process of osmosis using the tissue funnel as well as cellophane membrane. And in that process, what will happen is that you inside this is cellophane membrane bag. This bag, you will tie it around a tissue funnel. It's a very strong funnel, and you put some solution into this bag here. You put large amount of water into this one. Before you know it, water will move into the cellophane bag, and the water and the solution amount here will rise. If it rises, what happens? Osmosis has occurred from the region of what? Higher concentration of waters to the region of what? To the region of lower concentration of water. You can now see at the final level what happens. The level of the water here rises above the water surface. Are you getting me? That's about that particular solution. So here we have hypotonic solution. This is a blood cell inside hypotonic solution. What happens? All the blood will drain off. Now I must let you know that somebody can die from drinking large amount of water. You can die from drinking large amount of water. And how would that be possible? This will be possible because if you drink too much amount of water, the environment in your body will be in hypertonic state compared to your blood tissue. So therefore, this can lead to the fact that all the blood will lose their water solution into the water environment within you. And once that occurs, your blood cell will begin to plasmolyze, and the number of blood cells will begin to reduce. At a particular time, you will start to feel dizzy, and you will fall. You won't be able to know what you are doing again. So before you know it, you will be able to see yourself flying over the grasses or over flower. And in a few minutes, you may be seeing some cloudy experiment. You may be seeing some cloudy environment. And at a point in time, you will be able to see a tunnel. And at the end of the tunnel, you will be seeing tiny lights. At that time, maybe you'll be seeing some angels approaching you. You know that means? So be careful about the amount of water that you drink. Water is good for body, but avoid excess water. So it's one of those things that can kill if you don't control the amount of water that flow into your system. So this isotonic, this is a normal system. Why this is what? Hypertonic. A situation that can lead to high flow of blood, hypertension. Now, this is another means of osmosis performance. You can see in osmosis, what happens? It is not the solute that is moving. If you move the solute, you are performing diffusion. In osmosis, what is moving? It is water that is moving. It is water that is moving. The solute will remain, but the water will move into. So the water level will fall at one side and it will rise at another side, but the solute will remain the same. That's the reason why you should be able to know what you are doing. This process will have been diffusion. In fact, the process of membrane does not clarify. But what differentiates this process that it is a diffusion, it is a osmosis compared to diffusion is because you see only water that is moving. If water and solids move, that is both osmosis and diffusion. And if it is diffusion, particles will move from the higher concentration to lower concentration. You must be very, very careful, please. Now, this is exactly the way we perform dialysis. You will have a rod tube over your beaker. You will tie some rubber, a little one, across the dialytic bag. The dialytic bag is punched at both ends, so you will tie both ends. You put your solution into it. You tie the other hand. You put it into the solution. So water molecule and the small ions will be driven out. Your solution will become concentrated. So this is another means of performing osmosis. And this one is the typical tube experiment that we can use to determine osmotic pressure, because this is manometer setup. And here you can see you can see your membrane. I don't know, but by means they place that membrane inside this thing. If you happen to have this tube USB in your lab, you'll be able to see what it looks like. So here, what happens? Water will move from the region of higher water solute to this place. If you want to prevent that osmosis, you want to prevent water movement from this place to this place. So you have to apply pressure in this place. If you apply pressure in this place, the pressure that you apply here is called osmotic pressure. And you know how to apply that pressure. You can apply pressure by pumping here or gas into this place. So what happens? The pressure of the gas will be pressing over the surface of this water and opposing the water that is coming in here, so therefore preventing osmosis. And the water will remain at equal level. And the amount of pressure that you apply, can be known by noting the water differences level. Because before you apply that osmotic pressure, you must have let osmosis to occur, so that you will see the water level fall. Are you getting me now? Note that water level fall, and then note the water level rise in this place, and take their difference. And take their what? And take their. Let's say that the water has fall to this level, and it has rising to this level. So what happened here? The water level. Let me close this. Let me clean the board. So this is the equilibrium level. Are you getting me now? If the water level fall to this level in this place, are you getting me? And the water level rise to this level in this place. Are you getting me now? So the level is now equal to what? Is equal to all this. So from this place to this place. So this is the pressure. This is I of the pressure. If you understand pressure with respect to this particular formula, you'll be able to calculate the pressure that is applied to prevent that particular osmosis. Now, once you have let osmosis occur, you will now apply pressure to this place to let the water return back to the equal level. You have noted the height during the osmosis, then you will note the density of the fluid, that is, you will note the density of the fluid and your gravitational constant. So therefore, you'll be able to see how to measure the osmotic pressure. So this is the end of osmosis. But in this class, it seems that you don't discuss something about importance of osmosis. We are still going to discuss it because it's very, very important and that we look into it. But for now, we are out of the time. We are going to meet in the next class. Thank you for listening. ABP.